Hi everyone. Today we'll be making upgrades to my soap dispenser. Right, this is the current version of the soap dispenser. It works fine. Grab the sponge, put it underneath, goes off for 2 seconds, or it sometimes gets stuck. So you kind of have to put it up and then move it down immediately. It's kind of shitty. And the 2-second timer means when sometimes you want to wash your hands, you still get a crap ton of soap. No, you want just a tiny bit. This is the brain of the soap dispenser. You can see in here we have the Pico, which is doing a very simple task, and it's capable of a lot more. In here we have a piece of paper to prevent shorting, and then that goes to my hotter than I expected motor driver. I didn't realize that gets pretty warm now. And then in there we've got the pump. Oopsie. So there's all this in there, and there's the ultrasonic module that's in there. I'm hoping to get rid of this and get rid of the ultrasonic module, and now and replace it with an IR sensor, which most of the circuit is already integrated in it. So all I really need is the pump and this and the power. Everything else will be handled by the IR sensor. Let me just put this back, and I guess we can have a look at the prototype I'm working with. Let me explain the IR proximity sensor I'm using for this version. By default, the sensor sends out a high signal on its output pin. That won't work for my application because it would mean the soap dispenser is constantly running until I trigger it. There's 2 ways I can fix this. I can use a logic inverter, or I can just resolder 2 of the pins on the main board. As the quicker option, I tried resoldering the pins first. It works, but it comes with some caveats. For one, you can't change the distance at which you trigger the IR sensor. And second, I've noticed some funny behaviors. It seems to act more like a dimmer switch, getting brighter as you get closer to it, and that's just not a feature I want. So I moved on to making a logic inverter. Using a transistor and a resistor, I made this little circuit that inverts the high signal to a low signal, and vice versa. And this works pretty much perfectly. I can change the distance at which it gets triggered, and I'm not seeing any funny dimmer activity, so I'm gonna move on with this version. Now let's get into some 3D design. I do all my designing on my iPad in Shaper 3D, just find it a lot more intuitive than Fusion 360. It also has this cool feature where if you just shake the canvas, the design you want will just appear. If you want a closer look at my design, I've put it up on Thingiverse. Link is in the description. And from here we're just going to export it as an STL and send it over to my MacBook so we can print it. Over on my MacBook, all I have to do is put the designs into Kira, click slice, and then send it over to my 3D printer. 3 hours later, the print's finished. Right, all the 3D printing is done, and I removed the supports even though it looks kinda junk. Oh well. Yeah, this just should slide onto here, and it does. That's as flash as I'm gonna get it, and the lid pops on the top right there. That's pretty good. Let's move on to the electronics, starting off with the pump. It's a bit of a struggle to get it in there. I really don't want any kinks in the tubing. After a little bit of reconfiguring, it fit in fine. Now let's move on to the IR sensor. I've prefabricated holes for the diodes to fit into. I've also cut out holes either side of the sensor for a zip tie to hold it down. Now let's wire up the motor driver. Due to the limited space inside, I swapped out the heatsink for a smaller one. Let's start by plugging in the 12-volt input. Now let's add the 5-volt out and ground going to the IR sensor, and a single pin going from the IR sensor output to the motor driver to trigger the motor. Now let's wire in the pump, and last but not least, let's connect the IR sensor. Let's do a quick test to make sure everything runs properly. And yeah, everything looks good. Now it's time to gently squeeze everything into the container. A little bit of on-the-fly modification never hurt anyone. Let's put the lid and the casing on the sensor. Now let's just put it on top of the container. It looks pretty good. I'm not a huge fan of the tilt, but apart from that it's fine. For the testing I have the motor wired in backwards so I don't waste any soap. And at this point I found a problem that stumped me for about an hour. When I turned the soap dispenser on, it would just automatically stay on constantly, and I couldn't figure out why. I thought it might be the reflective surface, but I put a towel down and that didn't help. In fact, I covered the whole thing with the towel and that didn't help. I thought it might be a short, so I took it all apart, took it to my desk, tested it. It worked fine. Took it back, put it back in. Same problem. It wasn't until I was tired of this project where I turned off the lights and it stopped. So I had to look into this. What's actually happening here? The halogen light bulbs I have a light length wave of 250 to 1500. The invisible light length wave is from 800 to 1400. So my kitchen lights are literally just blasting my kitchen with invisible light length waves. We've previously installed LED lights anyway, so we just disconnected the halogen ones. And now it works perfectly, even if you want just a drop. And with that, the version 2 is finished. I'm still not fully happy with the design, but I can change that later on. Meanwhile, don't forget to subscribe, follow me on Instagram for updates. If you want to support me, I have a Patreon. For anything else, just follow my website.